Hi everyone, welcome to my YouTube channel. Hope you all are doing extremely well. So today in this video we are going to solve problem of the day on the Geeks for Geeks platform. So make sure to watch the complete video. But before proceeding further to the video, if you are new to this channel or if you haven't subscribed my channel till now, then guys do consider subscribing my channel. It will really motivate me to make more such content for you, and definitely the channel will be helpful for you. So do subscribe the channel right now, and one more important thing is that do join our Telegram community as well. We have many members there, right? So we do have a discussion, all sort of questions you can put up there, and like there are so many members, so obviously they'll be replying to you, helping you out. So make sure to join our Telegram community. The link for the Telegram channel is given in the description itself. So let's understand the problem statement now, right? So the problem says largest value in each level. This is an easy level problem, and even I do consider the same. So the problem says given a binary tree, find the largest value in each level. So basically, level by level, you have to determine the largest value in each level. For example, this is the input given 1, 2, 3. So in level 1, the largest value is this one only, na? That is 1. So we are getting 1. In this level, level 2, which is the largest value among 2 and 3? 3, right? So that's what we are getting. There are two levels in the tree. For 1, we have the value 1, maximum is 1. For level 2, we have two elements, 2 as well as 3, where the maximum is 3. Even example 2 they have given. So for this, what will be the output? 4, then 9. As you can see, 9 is the maximum in this level. Then 7. 4, 9, 7 will be our answer. So there are 3 levels in the tree. That is what they have explained in the explanation itself. So whatever task is, we have to complete the function largest values, which takes the root node of the tree as input and returns a vector containing the largest value in each level. Expected time complexity is big of n, where n equal to number of nodes. Expected auxiliary space is big of n. So constraints are even given. So what you must be thinking of to do? Well, this is a basically level order traversal that we have to do. So level by level we'll be doing the traversal, and there itself we'll be determining the maximum value. Let me give you a quick idea about the thought process, and probably then we'll be putting it up. So let's say this is the binary tree given to us, and as if I mentioned about the level order traversal, so what we'll be doing here is we'll be taking a queue, right? We'll be taking a queue. So level by level we are going to do the traversal. So first of all, in our queue we are going to put what? The root node, that is 4. That is what we are going to put into our queue. Now we'll be taking a loop. If you have done the level order traversal, you must be knowing about it. So we'll be taking a loop. As of now, we have to continue in this loop till the time our queue is not empty. So our queue is not empty, right? It is having one element. What is the size of the queue? That is 1 itself, as if there is just one node itself. So what we're going to do is, in this particular level, we are going to check what is the maximum element. Obviously, we have this 4 only, so this will be the maximum element. Then what we're going to do is, we are going to check that if this particular node that we have in our queue, if it has left child, yes, it does have. So put this into the queue, and if it has right child, put this into the queue, and then what we have to do, remove this particular element, remove this particular node. Okay, then again our queue is not empty. What is the size of our queue now? 2, right? Because this time we are having 2 nodes. Now first of all, we put this one now. So what we're going to do is we are going to take a loop till the size of our queue. So we are when doing the traversal, we'll be keeping track of the maximum element, right? So out of these two, 9 as well as 2, which is the maximum element? Obviously 9, right? 9 will be the maximum element, okay, from this particular level. Now out of this, what we're going to do is, first of all, we'll be checking for this particular node now. So we are also making sure that if this particular node has left as well as right child, put them into the queue and remove this particular node. Same we are going to do for this node as well, that if it is having left as well as right child, so left child is not there, right is there, so put this into the queue, and this particular node is also going to be removed. Now level 2 is also done. In level 2 we have the maximum value, that is 9 itself. Now we are on level 3. So for level 3, what is the size of the queue? Queue is not empty. And what is the size? 3, as if we are having 3 elements. So one by one we'll be checking for all the values that we are having in this particular level, that is level 3. And also we are checking that if the node that on which we are currently, if it is having left child or right child, we are going to put this into the queue. 3 is also not having, 5 is also not having, 7 is also not having any right as well as left child. Okay. And what will be the maximum out of these 3? Obviously 7. And we are going to pop these out. Okay, so now our queue is empty. So what are the maximum elements that we have got from each level? 4, 9, 7. Right, so that's what we have to do. So hope you must have understood. So when you'll be having a look on the code part, then also you'll be getting a proper clarity about the same. So let's have a look on the code part as well. So here you can see we have to return an array list of integer type that will be containing the maximum elements for every level, right? So that's what we are having, this array list res, and we need a queue for level order traversal. So that's what we have taken here. Now if the root is null, so simply we are returning this res, right? Now here we have a while loop where we are making sure that our queue is not empty. So you can see we have put the root node into the queue, so queue is not empty. Then we are determining the size of the queue, that is int n equal to queue dot size. And initially we have make an assumption, let's say that the maximum element have the value integer dot min value. Then we are taking another for loop that will be up to I less than n. Okay, so this will run up to I less than n, I equal to 0, I less than n. So we are popping out the element, popping out the node one by one, and we are updating the value of this max element according to the maximum value that we are seeing. So if the value in max itself is maximum, so it will remain as it is. Otherwise, if the current node that we have come across, the data present in this particular node, if this value is maximum, then that value is going to be stored in our max element. Also we are checking that the current node, if it is having left child, then add this to our queue. If it is having right child, then add this to our queue, right? So repeatedly we are doing these operation, and you know that after completion of one level, obviously what data max will be having, max will be having the maximum element that is present at that particular level. So here you can see in our array list we are adding res dot add max, and next time when next level will be traversed, again the value of max is going to be updated as an integer dot min value. And for that level also we are going to determine the max element, maximum value, that is going to be added to our array list. So that's what we are doing. Hope you must have understood the code part as well. So I have provided the code link in the description itself in case you want to check for the same. So this is it for this video, guys. I hope that you must have understood the complete question, logic part, and the code as well. Thank you for watching. Don't forget to share and subscribe our channel.